Alright, so today we'll be talking about the law of conservation of mass and the law of definite proportions. The law of conservation of mass states that mass cannot be created or destroyed, or, in other words, the total amount of mass in a reaction stays the same. And the law of conservation of mass was discovered by Antoine Lavoisier. The law of definite proportions, which was discovered by Joseph Proust, states that a compound always contains the same proportion of elements by mass. Example 1, it's an example for both laws, but I'm going to focus on the law of conservation of mass. So here we have sulfuric acid reacting with sodium hydroxide to form water and sodium sulfate. On the reactant side, we have 4 hydrogen, 1 sulfate, 2 sodium, and 2 oxygen. On the product side, we have 4 hydrogen, 2 oxygen, 2 sodium, and 1 sulfate. So, since the same amount of elements are on each side, the mass on both sides of the equation stays the same. Example number 2 is, again, an example for both laws, but I'm going to focus now on the law of definite proportions. So here we have hydrogen bonding with oxygen to form water, and on the reactant side we have 4 hydrogen, 2 oxygen, and then on the product side we have 4 hydrogen and 2 oxygen again. So because of the law of definite proportions, we know that water always has a 1:8 ratio of hydrogen to oxygen, or 11% hydrogen and 89% oxygen, because the mass of each element is always the same, and the formula for hydrogen or for water is always the same. So we can see the law of conservation of mass in the real world if you take a strip of magnesium, Bunsen burner, and tongs, and hold the magnesium in the Bunsen burner with the tongs. And because magnesium reacts with oxygen, when you burn it, it creates magnesium oxide. And so the mass of the magnesium and the oxygen combined in the reactant side is equal to the mass of the magnesium oxide in the product side, which shows the law of conservation of mass. So that's it, and thanks for watching.